so this is the Unit 3, Lesson 3, Part 2 video. Piecewise equations can be challenging algebraically. Sometimes information that we find from them can be misleading or incorrect. Exercise 3 says consider the piecewise linear function. We are going to skip over Part A, so we don't have to do A. However, we're going to do Part B. But before we do Part B, let's kind of break down some information about this piecewise. So x is less than 2 simply means that at 2 there is an open circle. And for the second equation, it says x is greater than or equal to positive 2. We know that that's going to be a closed circle at positive 2. So Part B says find the x-intercepts of each individual linear equation. So that means the first equation says 5 minus x. I'm going to set that equal to 0 and solve for it. So I'm going to subtract 5 on both sides. I get negative x equals negative 5. Divide by negative 1 on both sides. That means x equals positive 5. So that is one of the x-intercepts. The other one is 1/2 x plus 2, set that equal to 0. I'm going to subtract 2 on both sides. So I get 1/2 x equals negative 2. Then in order to get rid of the half, I'm going to multiply both sides by its reciprocal, which is 2 over 1. So these cancel, and I'm left with x equals negative 2 times positive 2 gives me a negative 4. So my actual x-intercept is going to be 5, 0. And my other x-intercept is negative 4, 0. All right, let's look at Part C. It says graph the piecewise linear function below. So remember, the first equation is 5 minus x. So I'm going to plot my y-intercept. So I'm going to go up to the top here, and I'll label this one red and the second one blue, and I'll graph that. So remember, it's 5 minus x. So my y-intercept is going to be 1, 2, 3, 4, 5. So right there. And from there, my slope is down 1 over 1. So it's negative 1 over 1. So from this point, I go down 1 over 1, down 1 over 1, down 1 over 1, and I'm going to go the opposite direction, up 1 over 1, up 1 over 1. So let's remember to look back at this restriction. It tells me that x has to be less than 2. So I want anything at the value of 2, which is here for my x, and it can be anything less than that. So I'm going to erase all values that are not less than 2. And also remember, we're not including 2, so it's an open circle at 2. So I'm going to draw an open circle there as well at 2. So now my graph looks like this. Then let's go ahead and graph the second equation, which is going to be in blue. So my y-intercept for the second equation is positive 2. So at positive 2 is where it crosses. And then from here, my slope is 1 over 2. So up 1 over 2, up 1 over 2, up 1 over 2. And I'm going to go the opposite direction. Down 1 over 2, down 1 over 2, down 1 over 2. All right, so remember, the restriction is this, is x has to be greater than or equal to 2. So at the value of 2, here I want all values that are greater than 2. So anything that's not greater than 2, I'm going to go ahead and erase. So remember, we said that the graph at positive 2 is included, so we're going to fill in the circle. So that means this point gets filled in. It's no longer open. And then I can go ahead and graph this equation. So this should be the graph that you get for Part C. Now Part D says Why does your graph contradict the answer you found in part B? Well, in part B, we found x-intercepts. Does our graph cross anything on the x-axis here? No, it doesn't. So because the graph does not have any x-intercepts, last exercise, exercise 4. For the piecewise linear function, you have this function given here. Notice I'm going to go ahead and highlight what's important. So it tells us that our x is less than or equal to 0 for the first one, and x is greater than 0 for the second one. It says find all solutions to the equation f of x equals 1 algebraically. So right now, they're wanting to know which equation actually satisfies the information given here. So it's saying f of x equals 1 is the same as saying y equals 1. So based on this equation given, which one actually makes the statement true? Well, 5x minus 1, x has to be greater than 0. So if x has to be greater than 0, we're going to use that equation because 1 is greater than 0. So I'm going to take 5x minus 1 and set it equal to my y equals 1. And I'm going to solve for x. So if I solve for x, I get 5x equals 2. Divide by 5 on both sides. That means x equals 2 over 5. And so because x equals 2 over 5 satisfies the second statement, that means that the information given is correct. All right, make sure you star anything or circle anything that you may have questions for us tomorrow. See you guys later.